Hello, welcome to another tutorial about Java data types. My name is Muhammad Asif and I have a lot of experience in software development, and I am here with a new tutorial about Java data types, and we will cover here the integer data type, and we will cover the specific uh, topic about integer overflow and integer underflow. So let us see what is integer overflow. So let us create a class. We name it integer overflow underflow example, just like that. So, and we can name the class anything we want, and then we type in main, and then in Eclipse I am using the Eclipse ID, so you can press ctrl plus spacebar and you get this Intelisense menu, and you can double click on this main method and it generates it. Okay, so now let us see what is the maximum value of an integer. So overflow is a condition where our value, the value we get from our expression goes beyond the range of the integer. So let us see what is the maximum value of an integer. So let us write it like this, and we have an integer wrapper class, so we you can use the max value, and this is a constant, and you can see it is showing the maximum value that it can hold. So let us write it here, and then we do sysout, we type in sysout, and then we can do the same thing, control plus spacebar, and we can double click on it and we get the system.out.println, and here we can write out max. So let us use the shortcut key again. This is control alt plus no, it is alt shift x, yes, alt shift x, and then J. So you can see it will generate this result in the console, and this is the output. So alt shift X, and then we get a menu, and in that menu we can press J. So this is a shortcut key for running the for running the Java application with main class in Eclipse IDE. So we use this shortcut. I actually use it. You can actually run it from here as well, and or you can right click and then you can run as this, and it is showing the shortcut key as well. So now, okay, so now back to the topic. So what will happen when we add 1 to this number? For example, we do again sysout and then we do max plus 1. So what will happen? It will actually go beyond this range. This is the maximum value that an integer in Java can hold. So what will be the result? The result will be something that is not a correct result. It is like you can see this is an unexpected result, or you can say it is an expected result as far as Java is concerned, but as far as mathematics is concerned, this is a bad result. This is not what we will expect. So don't ever use this integer type when you are calculating some big values, otherwise your program will have bugs. So you can use actually another value that is long, and you can check what happens when you do this. Will it keep the value or not? Let us see what happens. So, and we are printing it out, so let us see what it outputs. So it has output this same value as well. Why is it so? Right now we have the long here as the older variable, and still we get the same wrong value. This is because the result is calculated before it is assigned to the long value, a long variable. So this operation is already performed and it has the result which is this one, and then this gets assigned to the long. So what we will need to first um, cast this to a long value. For example, we can do it like this: long L is equal to long max plus 1, and now we will see what happens. Sysout and here L2. So now you can see the correct answer is printed out. It does not have the minus sign with it. So why this has happened? Because this value we explicitly cast it to long, and then we added 1. This is an integer, but when there is a larger value involved in an expression, then the smaller data type literal is actually promoted to the larger and wider data type. So it is also promoted to long, and then the plus operation is performed, the add operation is performed on these two values, and the result is then assigned to L2, and we get the correct answer here. So this is how we have to handle this overflow, and the same is true for underflow. For example, we have an int and min value, which is integer dot min value, and then if we sysout and perform 1 minus, and we can actually print this out, the min value, and then min minus 1. So you will see what happens here. Let us introduce a line here, and then we run it again. So you will see this value is unexpected as far as mathematical operation is concerned, but in Java this is what happens. So here we will also need a long value, and then you can see what is the max for long. You can print it out as well. So long upper class, then min value is here, and then there is a max value as well. You can write it down like this, and then you can see this is the maximum value the long type data type can hold, and this is the minimum value. So this is all what I wanted to share with you. This is how this integer, underflow and overflow conditions arise in Java, and you have to be careful while using Java data types, and you have to actually use larger data type when you expect larger values. So, and for example, in you have the option of using big integer, you have the option of using big decimal. We will discuss those data types in our next videos, and thanks for watching this video. Please subscribe to this channel, and please like this video as well if you find it helpful, and you can reach me out at my LinkedIn, that is also given in the video description, and you can even email me, and you can suggest me for any other topic that you want a video for. I will be making it based on your feedbacks. Thanks a lot.